we've got a circle split into 6 sectors, and then they're rearranged into this new shape with a circle kind of at the inside it, I suppose we should say, with a radius of 1. Work out the area of the curvy, unshaded region, so this bit in the middle. Okay, well, let's focus on the sectors. So if I just take the top one, for example, and just sketch it out. Then I can draw a line across it and split it into 2. That will necessarily split it into 2. So if I can work out this area here, then I'm sorted because it's just a circle minus 12 of these. Okay, let's give this a go. Well, we have a 60-degree angle up here because it was 360 split into 6. So we have an equilateral triangle, in fact. This will be 1, this will be 1, and this will be 1. So I can imagine splitting it into a half, and then we've got 1 here and a half here. Just split it down the middle. I've just drawn it away to try and make it a little bit clearer. So then this is a right angle. And what I'm saying is the height of this triangle, let's call it h, is going to be this h here. So h will be 1 squared minus a half squared using Pythagoras' theorem. Sorry, h squared. And that would be 1 minus a quarter, so 3/4. And therefore h is root 3 over 2. Okay, now let's work out the area of the triangle. It's going to be a half times base, which is 1. I'm now back to this triangle here, times the height, so root 3 over 4. And then the area of the sector is going to be pi r squared, pi times 1 squared, but then I'm going to divide by 6 because remember, I've split the circle into 6. So pi over 6. Okay, and we're getting there because that means the blue area is going to be pi over 6 minus the area of the triangle, root 3 over 4. Let me just backtrack at this point and just justify a few of these things again. So we've got our original circle. We know the area of it is going to be pi r squared, or pi in this case, because it's pi times 1 squared. Divide that by 6 to give the area of each of the individual sectors. That's what I have here. We can split the sector into an equilateral triangle and like a little bit that's left over, this bit here, because we recognize that if we can find that, then we can times it through by 12 and then just subtract it from the area of the circle. So we do the area of the sector minus the area of the triangle, and we've got the area of the triangle by using Pythagoras to get the height of this triangle, split it into 2 to leave a triangle with a hypotenuse of 1 and a base of a half. That gave us height of root 3 over 2, and hence the area of the triangle. Subtract them to give the blue area. And that means 12 times the blue area, which would give, like, I just want to say again, like all of these bits is going to be 12 bracket pi over 6 minus root 3 over 4, which becomes 2 pi minus 3 root 3. And hence the area of the unshaded region that is going to equal pi, the area of the circle, minus the area of these shaded parts, which is going to become, that's going to become pi minus 2 pi, but then this is a double negative, so it'll be plus, so 3 root 3 minus pi. Nice question to finish things. Really well done on your efforts on this challenge, and I hope you enjoyed it. Thanks for watching.